All right, let's talk about oblique asymptotes. We've talked about zeros, we talked about horizontal asymptotes, we talked about vertical asymptotes, y-intercepts sometimes, x-intercepts are the same thing as zeros. But now we've got these things called oblique asymptotes. So picture just a graph of the function below, and we have some of the features we can figure out already, right? So if I factor the numerator, nope, not like that. That's not how I do it though. All right, so features that I get, I know there are no horizontal asymptotes because the top wins, right? The top has a higher degree, so I get no horizontal asymptotes. Vertical asymptotes at the bottom equal to 0, you get x equals 0. Zeros, and that's why I factored the numerator. From this guy, we get x equals 2, and from this guy, we get x equals 1, right? So x equals 2 and x equals 1. Those are right there. The vertical asymptote of x equals 0 is happening here. But there's something else going on here, right? I don't know exactly what it is, but there's something going on, right? That's kind of leveling it off at this line. That's called the oblique asymptote. It's sometimes also called the slant asymptote, but it definitely exists. Like I can see it happening. The function's getting really, really close to that line, this slanted line. So in this case, the equation for the asymptote is the quotient you get from dividing out the denominator. And we're going to have oblique asymptotes when the numerator wins by 1 degree. They're called oblique. They're also called slant asymptotes. So if you do the division for this function, x squared minus 3x plus 2, you end up getting a remainder. That you get a remainder of 2, but the quotient is this x minus 3. That's this line here. That's my slant asymptote. So our slant asymptote in this case is y equals x minus 3. I'm going to show you that division. That's why I've got this spot here. So I'm taking x and dividing it into x squared minus 3x plus 2. Now, first thought is, what do I multiply x by to get x squared? And that's x. So this is a little weird, right? That canceled out. So bring down the negative 3x plus 2. Then what do I multiply x by to get negative 3x? That's negative 3. Those cancel out, and I just get the 2, right? So there's my remainder. So what that means is that x squared minus 3x plus 2 divided by x can be equivalently written as x minus 3 plus the remainder over what you divided by, right? So this goes right there. Your remainder goes right there. And then your quotient goes right there. That's what happens when we do the division. Now, this right here, the blue, the quotient itself, that's your slant asymptote. So you can get the slant asymptote from once you're done the division. The vertical asymptote you can get before or after. Zeros I would get from before. It's going to be easier to get our zeros there. Okay, let's do something. Find the zeros, the equation of the vertical asymptote, and the equation of the oblique asymptote for f of x equals that thing. Okay, I'm going to try and partition this up a little bit. Let's do the vertical asymptote first, just because I think it's the easiest. Set x minus 1 equal to 0. You get x equals 1. Vertical asymptote done. Let's do the zeros next. To get the zeros, I got to factor. So 2x squared plus 5x plus 3 equals 0. So 2 times 3 is 6. I think 2 and 3 will do it, right? Those add up to 5. 2x squared plus 2x plus 3x plus 3. In the first two, I can take out an 2x, actually. I'm left with x plus 1. Here I can take out a 3, left with x plus 1. So that's x plus 1, 2x plus 3, which gives me x equals -1 and x equals -3/2. So those are my zeros. Now, the slant asymptote's the most work, or the oblique asymptote, because we have to do division. All right, what do I multiply x by to get 2x squared? That'd be 2x. So then 2x times x gives me 2x squared. 2x times -1 gives me -2x. Wrap it up and subtract. Those cancel. 5x minus -2x is 7x. Bring down the 3. What do I multiply x by to get 7x? I believe that's a 7. 7 times x is 7x. 7 times -1 is -7. Wrap it up and subtract. We get a remainder of 10. So what that means, our function f of x can be equivalently written as 2x plus 7 plus 10 over x minus 1. And my slant asymptote, or my oblique asymptote, they're synonymous, is y equals 2x plus 7. So there's all the pieces. Now that I have all the pieces, I need to graph it. Let me write down, we had a vertical asymptote of x equals 1. We had zeros of x equals -1 and x equals -3/2. And then we said our slant asymptote or oblique asymptote was y equals 2x plus 7. That's going to be the last thing that I'm going to put on here, but let's put our zeros on first. Our first one is -1. Oh, these are very close together. And -3/2. Those are right next to each other. Then our vertical asymptote is at x equals 1. I'm going to do this a little thicker. And our slant asymptote is 2x plus 7. So we got to put our algebra 1 hats on. Remember, that's the y-intercept. And then that's my slope. So up 2 over 1. And then I can also go down to left 1. I have no idea how much I'm going to need. Okay. Now, because of the zeros, I know that I have to go something like this. I really need to round that out a little bit better, but because those zeros are so close together, it's a little hard. Now, the other half of these rational functions, they're always in the opposite corner. So I don't know exactly where it is, but it's kind of like there. Something like that. A little ugly, a little gross, but it works. It's done. All right, let's do another one of these. Find the zeros, the equation of the vertical asymptote, and the equation of the oblique asymptote. Like I said, vertical asymptote is my favorite because it's the easiest. You just set the bottom equal to 0, and you get x equals -2. Now let's go find our zeros. We have to factor for that. So 3 times -4, that's -12. I think +12 and -1 will do it. All right, let's look at the first two. What can I take out? 3x. I'm left with x plus 4. Now let's look at these two. I think I can take out a -1. So I get x plus 4, 3x minus 1, which gives me a 0 of -4. And a 0 of 1/3. Okay, these are getting progressively more difficult as I move through them, right? Vertical asymptote's the easiest, then 0 is a little more difficult, and now I need to actually go through and do some division for this last one. So x plus 2, 3x squared plus 11x minus 4. All right, what do I multiply x by to get 3x squared? That should be 3x. 3x times x is 3x squared. 3x times 2 is 6x. Subtract. 11 minus 6 is 5x. Bring down the negative 4. And then we repeat. What do I multiply x by to get 5x? I believe that's a 5. So 5 times x is 5x. 5 times 2 is 10. Cancel. And that's negative 14. Okay, so then f of x can be equivalently written. I guess I'll keep it in orange. 3x plus 5 minus 14 over x plus 2. And my oblique asymptote, or my slant asymptote, whichever one you want to call it, it doesn't really matter, is y equals 3x plus 5. Now I bet on the next slide we have to graph it. Look at that. Okay, so the vertical asymptote was negative 2. I'm just copying these down from the previous slide. That way we have them. X equals 1/3 and x equals 4, I think. Oh, negative 4. And then our slant asymptote was y equals 3x plus 5. Okay. Vertical asymptote, negative 2. Zeros at 1/3. Oh man, I don't know. Like there. And negative 4, so there. And then my oblique asymptote, 5 is the y-intercept. And we've got 3 over 1 this time for the slope, so up 3 over 1. And then I got to go backwards too. Backwards always, I'm a lot slower for some reason. Okay. Now this time you notice we got zeros in the opposite spots. So back here, we had 2 zeros in like one of the sections. We got them in opposite places this time, so it's not a big bother to me though. Something like that. I didn't go through it perfectly. And then over here, get close to the asymptote. Get close to the asymptote. Something like that. It's not perfect, but I'm happy with it. Okay, bye.